The squeeze theorem. Suppose you have a function y equal to f of x. Also look at the graph here. This is the function y equal to f of x. The other function y equal to g of x, which is here in red. And then y equal to h of x, which is this one in the middle, the blue function in the middle. All defined for the values near x equal to a. Suppose this point here on the graph is x equal to a. So for all values near x equal to a, those three functions are defined and they satisfy this condition. F of x is the smallest and g of x is the largest. Or you can say this h of x is in between g of x and f of x. Or when you look at it very carefully, you can see h of x get squeezed between g of x and f of x. Okay, h of x is squeezed between g of x and h of x. That's the meaning of this one. F of x is less than or equal to h of x is less than or equal to g of x. Or in other words, h of x is in between f of x and g of x. So in that case, what we do is, in order to find the limit of this middle function, we find the limit of this f of x, the function which is the smallest. For example, the limit of f of x is L. And also when you try to find the limit of g of x, suppose that is also equal to L. If the limit of the function, the smallest function is L, the limit of the largest function is also L, then the limit of this function, which is the squeezed function, that will also be L. So that is called the squeeze theorem, because the limit of the function which is squeezed in between these two functions will also be equal to the limit of those two functions, which is squeezing that function in the middle. Limit using squeeze theorem. Example, evaluate the limit, that is limit as x approaches to 0 of x times sine of 1 over x. Here, if you try to find this limit, we'll not be able to find this limit by direct substitution. Because if you try to substitute 0 here, it will be 1 over 0. 1 over 0 is infinity. And sine infinity, we don't know. When you go to infinity, when you go to infinitely positive, your sign is still fluctuating between 0 and 1. And we don't know what is that exact value. So we don't know whether this value is finite or not. So this is the infinity multiplied to x. The value of x is 0. And 0 times infinity, we don't know what is that value. If it is 0 times a finite value, it is 0. But here, it is creating 0 times some unknown value. So we don't know what is the result. So we cannot find this limit by direct substitution. So what we are going to do is, we are going to use this squeeze theorem somehow by using some known fact. This is what we know from trigonometry. Let me write that here. We know that the value of sine function for any angle is between -1 and +1. This is what we know from trigonometry. Sine of any angle here, this is the angle. Sine of any angle is between -1 and +1. This is the known fact from trigonometry. Or now, by looking at this, what you can say is sine 1 over x is squeezed between -1 and +1. But we are not asked to find the limit of sine 1 over x. Instead, we are asked to find the limit of x multiplied to sine 1 over x. So we have to multiply this by x. If you want to multiply here by x, you have to multiply this one by x and that one by x. So let's multiply throughout by x. So if I multiply throughout by x, -1 multiplied to x, that is -x, less than or equal to, we are multiplying by x, so x times sine 1 over x, less than or equal to x times 1, that is equal to x. So now you can see x times sine 1 over x is squeezed between these two functions, -x and +x. Now what we have to do is, we have to find the limit as x approaches to 0 of this one on the left and this one on the right. Let's find it out. What is that value? Now, limit as x approaches to 0 of negative x. So this is a polynomial function, so you can perform direct substitution. If you plug in 0 for x, it will be negative 0, which is just 0. And also, the limit as x approaches to 0 of x on this side. If you want to find the limit of this one, this is also a polynomial function. You can perform the direct substitution when you plug in 0 for x. So this is equal to 0. So we saw that the limit of this function, the smallest function, is 0. The limit of the largest function is 0. So the limit of this squeezed function is also 0 by Squeeze theorem. So we can write by Squeeze theorem, the limit as x approaches to 0 of x times sine 1 over x, that is also equal to 0. So we use Squeeze theorem to find this limit, and we saw that the limit is equal to 0. Limit using Squeeze theorem. If 1 minus 1 over 6 times x squared is less than or equal to sine x over x is less than or equal to 1, then evaluate this limit as x approaches to 0 of sine x over x. So you can clearly see sine x over x is squeezed between these two values. This is one, this is the other one. So let me write that. Here, on the smallest value is 1 minus 1 over 6 times x squared is less than or equal to sine x over x is less than or equal to 1. So since this function is squeezed between these two, we are going to find the value of this smallest function, the limit of the smallest function, and the limit of the largest function. Let's try that. Now, the limit as x approaches to 0 of the function on the left, 1 minus 1/6 x squared. So this is a polynomial function. You can find this limit by direct substitution. So it will be 1 minus 1/6 of, if you plug in 0, 0 squared is 0. So 1 minus 1/6 of 0, 1/6 times 0 is 0. 1 minus 0 is 1. So that is the limit on the left. And if you want to find the limit on the other side, we are calculating the limit of this constant. Limit as x approaches to 0 of a constant. Limit of the constant is always the constant itself. That's what we know from the limits law. Limit of the constant is always equal to the constant. If here is 5, it will be 5. If here is 7, it will be 7. If here is pi, it will be pi. So limit of the constant is that constant only. So that is 1. Now you can clearly see the limit of the function, the smallest function, is 1. The limit of this biggest function, that's also 1. So since these two limits are equal, the limit of the squeezed function must be 1 by Squeeze theorem. So let's write that down. By Squeeze theorem, limit as x approaches to 0 of sine x over x is equal to 1.